Sometimes her requirements don't just go.
It happens. It's fine. All right, definite interval. So things that we can now say about our interval. Hey, we just started. We have our integral. If you flip your upper and lower limits, it does the opposite. It flips your sign. So it's like if you're doing, we know the interval is like area under the curve. If you're going backwards, it flips the sign. Okay, so if you need to flip those upper and lower limits, you just throw a negative in front.
Why would you? Wait, how would you like, would you have to distribute that negative to the whole problem? Or?
You would evaluate the limit, or evaluate the integral, and then it would be the opposite of that. So if you got 5, it would be -5. If you got -5, it would be +5.
So you just like draw an arrow.
Yeah, pretty much, or carry a negative down front.
Why would you need to do that?
Okay, yeah, just hold that thought for a while. If you're starting and ending point are the same for whatever reason, if you have a problem that comes up like that, it's 0. Which would make sense. We know an integral is like area under the curve. If you start here and you end here, you don't have anything to find the area between. So it's 0. But the big thing, this is important. We have been calculating these by doing the sums, right? And we talked about upper and lower, left, right, midpoint. To approximate it, we said if we wanted the true thing, we would have an infinite number of rectangles, and so we'd have to do the limit as the number of rectangles went to infinity. Well, turns out, that's really the antiderivative. And don't we know how to do antiderivatives? Yes. So an integral is really just saying the antiderivative. And if I give you limits, you can plug those numbers into the antiderivative and evaluate it. So you have to do the antiderivative, you plug in your upper limit minus what you get when you plug in your lower limit. So that's what we're going to practice today. So instead of doing this with an infinite number of rectangles, we can say, okay, what is the antiderivative of x squared?
I have 1/3 x squared.
Now, in the past, we have always put a plus c on that, right? So hold that thought for just a second. Notation-wise, a lot of times you'll see a bar at the end, and this 0 to 3, that's just reminding you at this step, I need to evaluate it from 0 to 3. So what this means is you can plug in the 3, so 1/3 times 3 cubed plus c, minus, I can plug in my 0. Okay, 3 cubed is 27, times 1/3 is 9. So we get 9 plus c, minus, this would be 0 plus c. What happens to my c's?
They cancel, get 9.
They cancel, we just get 9. The c is always going to cancel. So if you have a definite integral, if we have numbers to plug in, you can totally just leave off that c, because it'll always drop when you do the first one minus the second one. Now, if I don't have numbers to plug in, we need the plus c. So if I just ask for the antiderivative, you need the plus c. But because we're actually calculating the area from one point to the next, we could leave that c off. And our area is just 9. Much faster than doing all the work that we have been doing to evaluate these. So this is what we're practicing today. Alright, this one is a more generic one. We're not going to get a number answer, but it's just really testing if we understand antiderivative. The dx tells me x is the variable, n is just representing some constant. So when you do the antiderivative, what do you do to your exponent? So what goes in front?
1/n plus 1.
And I have to evaluate that from a to b. Alright, you would, the 1/n plus 1 is just a coefficient. If you would like, you could pull that out in front. That's completely up to you. So you could write your final answer 2 ways. If we did it with each of them, we know it's 1/n plus 1 times b to the n plus 1, minus, if I put in my a, 1/n plus 1 times a to the n plus 1. Or, if you pull that out, 1/n plus 1, b to the n plus 1 minus b to the n plus 1. Either of those would be acceptable. from 0 to pi of sine x dx. What is the antiderivative of sine?
Cosine. Negative cosine.
Yeah, the derivative of cosine is negative sine, so it would have to be a negative cosine. I'm going to evaluate that from
Wait.
0.
Oh, yes,
The pi.
yes.
So if I put in a pi, negative cosine of pi minus, and then I put in my z. So what is the cosine of pi? Negative 1. So the opposite of negative 1 would be 1 minus a negative plus, what is the cosine of 0? And 1 plus 1?
Cosine is the y, right?
X. Sorry, I'm unit circle. Cosine's x. Sorry, one of those cases where I agreed before I listened to your question.
Well, I used to have a way to remember it, and I think it was just because we learned sine first, so it was second. Like, I just.
Cosine, I think C comes before S in the alphabet. So cosine's an X and sine's the Y. Alright. Why don't you guys try this one?
Or purple.
Like that. So the antiderivative will be 1/6 x to the 6th. You're going to evaluate that from 0 to 2. You could pull the 1/6 out if you want, just put in 2 to the 6th minus 0 to the 6th. 2 to the 6th is 64
Oh, you do the b minus.
minus 0.
So,
Yeah, top minus bottom. Over 6 or 32 over 3.
yes.
Let's keep practicing. Alright. So what is the antiderivative of 2x?
X squared.
Okay, what is the antiderivative
Attention please, the following is a direct.
Line.
x? When we add 1, it's a positive 1/2, so we just need our 2. We keep the subtraction.
Gosh, it's like it never even happened.
Antiderivative of 3.
3x, sorry.
And why don't I have to put plus c's?
Because we have numbers.
They would cancel out. Yep. Okay. So if I put in my 9, 9 squared is 81 minus 2 times the square root of 9. So 2 times 3 is 6 minus 27. And if I put in my 1 minus 2 minus 3. Okay.
Minus 4.
Minus negative 4. So we get 52.
You okay? You not see that?
I wanted to know, we were down there getting eaten by a tornado and I was thinking about what the derivative was.
Next time, just take your notes with you. So
I
you
was just gonna keep doing it, but I didn't realize that we had to go do it. Cause like for all the other drills, we don't,
I need to have a
besides fire.
Like, I need to see one of those before I die.
You need to see what?
A milkshake with a Twizzler as a straw. Like, I need a diabetic,
Okay.
what is it called?
Coma?
Infection? Yeah, infection.
Alright, so we have to think about this a little bit more. We could multiply it out 3 times, or we could think about chain rule in reverse. So if I add 1 to my power, it would be
4.
inside stays the same, but when you do the derivative, the 4 would come down, so we need a 1/4. And you would also have to multiply by the derivative of the inside, which is 2. So to cancel that, we need
2x.
a 1.
Oh,
Because the antiderivative of, or the derivative of 2x is 2, so you need a 1/2 to cancel it. So our antiderivative is really 1/8 times 2x plus 1 to the 4. Do you guys understand how we got that?
Yes, ma'am.
And we're doing that from 0 to 1. So So you could put the 1/8 with each of them. I'm just going to pull it out. If I put in a 1, 2 times 1 is 2, plus 1 is 3. I get 3 to the 4th minus 1 to the 4th is 1. So 3 to the 4th is 81 minus 1 is 80, and 1/8 times 80 is 10.
If I could draw an 8.
Alright. You guys want to try that one?
Sure.
Derivative of sine is
Negative cosine.
negative cosine. We know when we do that, the angle would stay the same. Times derivative of the angle. Derivative of 2x is 2, so we need once you evaluate from 0 to pi over 2. We need 1/2. If I put in pi over 2, 2 times pi over 2 is pi. Put in 0, it's cosine.
Yeah, why do you have a pie on the outside?
I don't know.
I thought maybe she had just like.
I think I was
thought
looking
she
at
just
that.
matched something even harder than I was doing.
Just making sure you're
Wait, why is that pi? Oh, I did that dumb. So
What's?
are we not?
I did it wrong. I didn't say anything.
What's the cosine of pi? Close. Think about it on the unit circle. Here's pi, cosine is x. Cosine of 0 is 1. So we get negative 1/2 times negative 2. The final answer is 1.
Oh my! Why can't I do math?
Is it the adding and subtracting that got you?
No, well I did my pi wrong, so then I tried to, when you told me what the pi was, I tried to do it really quick, and then negative 1 minus 1 is negative 2 times negative 1/2 is 1/2.
It happens. Look at the last problem. We don't know how we got there. You okay?
I'm really
We'll figure out
struggling with the
what it's
derivative of trig functions.
Yeah, trying to remember all those.
Well, it's fine with just cosine and sine, but then you flip up your negatives, and then it's just. Secant is just tangent squared, right?
Well, the derivative of secant is tangent squared. So this time I'm thinking, we have a product. We don't have a product rule in reverse, but does anything have a derivative that is secant x tangent x? The derivative of secant is secant tangent.
Oh, okay.
So we have the secant of pi over 4 minus the secant of 0. So pi over 4 is like 45 degrees. Cosine of 45 is radical 2 over 2, so secant is radical 2. Cosine of 0 is 1, so secant is 1. So we just get radical 2 minus 1. Let's do 2 more, and we'll stop for today. So if I ask you to evaluate this, a square root is like what power?
1.
So when you do the antiderivative, you add 1, so it would be,
2/3.
so what has to go in front?
2/3.
Okay, we know the inside stays the same, but you have to multiply by,
1/3.
derivative of the inside is 3, so we need another 1/3 in front. So it's 2/9 times 3x plus 1 to the 3 halves. I'm evaluating from 1 to 5. So if I plug in my 5, 15, 16 to the 3 halves, or the square root of 16 cubed. I put in a 1, 3 plus 1 is 4, so it's square root of 4. Do you guys know how I got that? Square root of 16 is 4, 4 to the 3rd, 64. Square root of 4 is 2, to the 3rd is 8. 64 4 minus 8 is 56. So 2 times 56 is 112.
Oh, the word problem.
Last one. Suppose an animal population, P of t, initially numbers P of 0 equals 100. So at time 0 there was 100. And the rate of growth is given by this equation. I want the population after 10 months. So if you're going to integrate from 0 to 10 of my equation, what would I have to do with the fact that at time 0 we started with 100?
Add. What did you say?
It told us,
Add 100 somewhere.
yeah, we can actually say it told us that at the beginning we started with 100. This is telling us, when we do this antiderivative, that will tell me how many were added to my population during that time. So to get the total population, we have to add the 100 we began with. Alright, so the antiderivative here, antiderivative of 10 would be antiderivative of t, antiderivative of 0.6 t squared. I'm doing that from 0 to 10 and just keeping this 100. So if I put in a 10, 10 is 100, 10 squared is 100 divided by 2 is 50.
Why was it the 100 included in that?
Because that was just the starting population. This is going to give us how many were added to it from that time.
So we don't have to put the.
Yeah, it wasn't
Would it really
part.
make that big of a difference if you put it on the outside?
Like, are you saying if you put it in this integral?
No, put it like outside of the plus 100.
Oh, no.
I didn't know that was just like a notation thing.
Yeah, I'm just putting, once we get this answer, we're just going to add 100 to the end. What am I doing here? I lost my,
220.
oh, yeah, I just threw an extra.
You were right for a second.
Yeah, and then I lost my train of thought. So we get
270.
We're stopping here for today, so I have